Okay, hello everyone. Hello. Wow, full house. First of all, is there anybody here not understanding or speaking German? I can do the talk in English and German both. Like, raise your hand, just, okay, like 2, 3. I hope we all find them when I'm doing it in English, even with my weird German accent. On the other hand, it's probably kind of a good thing because I'm speaking English all day already, and you probably would have heard like a lot of English all the time. So that's just now the original. The talk is called The Road to Continuous Deployment, and in the next hour I want to talk about what continuous deployment actually is, what it means for a company, for a development process, why you should actually do it, what the benefits of continuous deployment are, why you should care about this at all. Pardon? Ja. Okay. There's also no light on here. Hello? Better? Hello? Test. 1, 2, 3, 4, 5, 6, 7. No. Maybe the batteries. There's unfortunately no button on here. But I can.
Aber ich glaube, aus ist es nicht.
Yeah. Let's also try this one. Better? Hello? Does it work? Okay. I can also use this one if it's better. It's just like a bit of handling all the buttons and things. Okay. So this is better from volume-wise? Okay, awesome. If it appears like if it's too low at some point during the talk, just throw stuff at me. That I notice that, and then I can also try to speak up and probably have a sore throat later on. Here's like one slide over here. Okay, so as I said, it's going to be about what continuous deployment is in this talk, and why you should care about it, what the benefits of continuous deployment are, and introducing this in your application and in your development process, and what steps you can do, should do to introduce continuous deployment in your company, and what can you maybe start already doing like next week when you're getting back to the office on Monday to improve your development process and go onto the road of continuous deployment. Before we start with that, a few words about me. I work at a company called ResearchGate here in Berlin. It's a social network for scientists and researchers trying to connect researchers of different fields with each other so that they can collaborate with each other and maybe get the next scientific breakthroughs faster than with the traditional publishing model. We have about 5 million scientists online. That's what the profile looks like. It's all about publishing scientific content there. We have some investors. We have table tennis, snooker. We are hiring. We have a big room and elephants, and we have visitors sometime. And if you have any questions about that, ask me later on. If you have any questions on topic, like just raise your hand and we can handle them directly. If we don't understand anything, or if you want me to go into more detail on something, we can do this ad hoc, or at the end of the talks we also have plenty of time for questions. The slides will be on speaker deck later on, and probably also linked somewhere on the SymfonyLive homepage, I guess. So that's also a bit about me. What about you? Who's working for a company, like it's one engineer for one company with a bigger team? More than 3 or 2. Okay. Who's working as a freelancer more or on their own for customers? Okay. Who's working mostly on one product, like you have one big product, one online shop or something, or one scientific social network? Who is working in more like an agency environment where we have more like several different products? Like it's half-half, okay? Then just raise your hand if you know it, use it somehow. Do you use continuous integration in your companies or projects? That's awesome. That's very awesome. Continuous deployment. Okay, why are the people here that are doing continuous deployment? Maybe to get something new. Who's using feature flags? Who saw the talk of Benjamin about feature flags this morning? Wow, awesome. Who's doing central log management? It's a bit less. And who's measuring key performance indicators and plotting them in real time? And okay, that gets less and less. If you think, okay, I'm not quite sure what this weird guy on stage is talking about with all these acronyms and things, you will know after the talk. And hopefully also start using kind of these things because they are kind of cool. So, continuous deployment. In short, continuous deployment means that you should deploy code changes to your production environment continuously. That was basically the explanation of the term. If we look a bit back, what the classic approach on software development is, it's oftentimes in history more something like a waterfall process, which means you have some requirements that are in big product requirements documents that are probably book size. Then some software architects make out of these product requirements a software design. Then some programmers implement that. And then there are some testers testing the software in the end, and then it gets deployed and you fix then all the bugs. And if at any kind of a stage, for example, in implementation, the programmers see, the architecture does not really fit and it's getting too cumbersome to implement something, you go back to the design board, the software architect designs something new and goes down again. This is actually a valid approach for software development. In some environments it works quite well, especially if you ship software once a year via a CD-ROM or floppy disk or some binary download file that is 500 megabytes old and you have to download this over 56 kilobyte or kilobit internet connection. But if you think about the web environment where you actually can change your code every second and instantaneously your users are using this code, this whole big process seems like a bit of too cumbersome. Next to many others, this is like kind of one of the reasons why the agile development movement came to be, because people thought, okay, we have to be quicker, we can change our development process to have better quality software, to react faster, and to not have to wait 1 year to get new features to our users. Basically, they are working all kind of the same-ish. You have short iterations of where you develop some software, you have a backlog of things, of stories, of features you want to do. And in every of these iterations or sprints, you do kind of these stories. There are differences, how you measure, how you plan it, of course, and everything. And at the end, you deploy it when you're finished. And you have small changes of where you iterate over your software and make it better and better until the software is complete, your project is complete, and the next one comes in. In the standard approach, you have the iterations of 2 weeks, for example. Let's say you develop for 2 weeks, and at the end of the 2 weeks, you have a release. You put all this stuff online, you probably have to fix a few bugs afterwards, and then everyone is happy, hopefully. We could go further with that, because changing the code 2 weeks, waiting for 2 weeks to get results on something, to fix a bug, to change something, is still kind of slow. So going further, we are at continuous deployment, doing it not only every 2 weeks, but maybe every 10 minutes, every hour, however we want it. There are benefits to it, to deploying in very short iterations very often each day. You're deploying much smaller change sets of code with every deploy. That means the amount of lines of code you're changing is much smaller, and hopefully also the people that develop the code still remember what it was for and why they wrote it like this, and it makes it then easier to find bugs. You also deploy less bugs, because less code means less bugs. That's really actually a very easy correlation. As I said, finding the bug is much easier because you probably only have to scan like 100 lines of code or 250 lines of code and not like 10,000 lines of code changes. That also means if you deploy very often and have very small change sets, that fixing a bug is probably faster and easier because it's still in the mind of developers who developed it, how to do it and how to fix a bug. And because you're deploying very often anyways, the bug fix goes out very quickly as well. So you have the shortest time to bug fix possible when you're doing continuous deployment. And all this is not only valid for software quality and bugs in your software, but also for performance. Could be that you're introducing a new feature, you're forgetting to add an index to a query, and everything goes very slowly. If you just deployed one change there, it's immediately you see, okay, this is the culprit, this is why my site is now much slower than it was before. If it was in the change set of 2 weeks, it takes probably a few hours more to find what went wrong. Same with conversion rates. If you're measuring your key performance indicators, measuring conversion, for example, how many people that go to your site actually also buy something on there, if suddenly these figures drop, it's very easy to find out why. If it's a code change, maybe it isn't a code change, but if it's a code change, it's easier to find out why and fix the problem. Like, in general, it allows you to faster iterate over something. And also to incrementally make your software better. More to that later. So you say now, okay, this is all awesome, I'm sold. I want to do this. So, how? How can you introduce something like this in a company? Of course you can say, just I'm deploying more often, and that's it. I'm not changing anything about my process. I'm just deploying more often. It probably will fail there. Been there, done that. The key to that is that you have to think a bit differently when doing continuous deployment about your developing process, about software quality, and the whole team has to go with it. Otherwise, only a few people do this, and other people are still working the same way they worked before, and you get like bugs all the time, and broken releases, and fatal errors in your application, and so on, which is not nice. It's not only about doing more releases. And it's also a good way to introduce stuff like that, what I'm talking about, the steps to go to continuous deployment step by step and not only in completely all at once, because it's like, it would be a huge task to introduce everything, to change everything about it, and probably also you will overwhelm some people who cannot cope with that many changes at one point that well. First of all, of course, quality is very important. We want to have bug-free software, or as bug-free software as possible, and especially if we're deploying all the time, we have to care about quality, because we don't want to spend all the time when doing deployments bug fixing. If you look at some projects, in the quality or testing strategy, manual quality assurance is a big thing. Who's doing manual quality assurance in their projects? I think everyone does at some point, just clicking somewhere, seeing if the site still works, and then doing a refresh and after the deployment, the site still works. Awesome. It's perfectly fine to do manual QA at some point, but if you really want to test everything, see that everything works, also maybe the sign-up process that only like 100 people per day are using, and not see the next day that some figures are dropped there, it's probably not that good to only rely on manual QA, especially if you're doing multiple releases a day and would need to do this manual QA process all the time, 20 times a day. That does not really scale. So you should do automated testing. I guess you all of you are doing automated testing, stuff like unit tests, integration tests, where you have like larger parts of the software integrated to test against databases, maybe some acceptance tests where you actually test also the front end with stuff like Selenium, depends on your environment, maybe some smoke tests to see, hey, is actually my site working, this git refresh thing, automating that, maybe JavaScript tests, writing tests for your bugs, and so on. So when you do continuous deployment, automating the test suite is important. It's not about only writing tests, but also about doing continuous integration, and as I saw earlier, most of you doing continuous integration, you use probably something like Jenkins, so here on this scale, you're actually all fine. You have, with every commit, all your tests are running, and you can be quite confident that this new change that you're doing at least did not break anything that you wanted to test before and that you were aware of. It gets a bit more, now you're quite well with tests and you have everything, you should do this anyways, of course, also if you're not doing continuous deployment. What's more important is your development process. Especially in bigger projects, experience has shown that doing feature branches is kind of a bad thing, especially if your project grows bigger and if you deploy constantly and want to deploy constantly. Why is that? And what do I mean with feature branches? Like, feature branches work like that. You have like one trunk or master branch, and for every feature you're developing, you branch off there. You develop all your features with on your own or with a small team. You commit in the branch until the feature is finished, maybe also checked off by the product management or by testers, and then you merge it back to trunk and it gets deployed. Or you merge it back to master and then it gets deployed. Whose development process is somehow looking like this also. Yeah. Problem is, if you have more than like 1 or 2 teams and if you want to deploy your stuff constantly, it very quickly looks like that in a larger code base, which is kind of not ideal anymore. As when you end up in kind of a merge hell where one team is changing something code there and one team is changing code also there, and then you merge it, you get conflicts, you have to really resolve them, and in the end, the most important thing, like this is tedious anyways, but the most important thing why this does not work anymore is because you're again back to doing big changes and deploying big changes. Even if you do like 20 releases a day, if you have feature branches and developing your stuff in feature branches, then merging it back, you have a huge change set of code that you're currently suddenly deploying. And also, you have a huge change set of code that is integrated back into your trunk or master branch. That means the whole benefits of continuous integration, where you test all your changes with all the changes of other ones, and with every commit all the tests are running, you don't have that with feature branches. Of course you can set up all the tests on your branch as well and let them run in continuous integration, but you don't test it against the stuff other teams are doing at the same time on the same code base. Another approach for that tries to solve these problems is saying, okay, we just have a trunk or master-based development process. That means every developer, every feature, they just commit into the master branch. Every commit automatically gets integrated. The tests run against the whole code base as it is at the moment. And also, potentially, every commit can get deployed. That means you should, of course, not commit something that is not stable. Otherwise, something probably things would break. This is kind of a very harsh thing, and probably you want to have the possibility to have maybe some unstable commits somewhere and not break production totally. So there is like an intermediate approach where we say, okay, we have a master branch where everybody develops in, commits in, and then like once a week or once a day we branch off the release branch from that. We release from this release branch constantly, and what we want to have like in between creating new release branches there, we just merge or cherry pick over. Would look like this. So we have our development main branch here, and this is a weekly problem iteration. You just branch off a release branch. You maybe cherry pick some commits and merge them in a release branch with bug fixes that you want to have, or small features that you want to have out earlier, and then you just release from this branch, and the next week you branch off a new release branch. And you can also do this daily if you wanted to. This is actually an approach that it works very well at companies like Google, Facebook, and that really scales very well. But still, there is probably stuff that I want to develop that takes longer than like a day or a couple of hours to do. Where I want to say, okay, I want to develop something, and for legal reasons it should, or because it's so much work to do, users should not see it before it's actually done. It's actually a good concept theory that users only see stuff that is done. What is helping us with that, with master or chunk-based deployment, is feature flags or feature tokens. You saw that earlier with Benjamin. That means you're actually making the deployment of code independent from the release of code. You're deploying the changes, everything is integrated, but it's released to your user base only if you wanted to, if it's really ready. You can still test it very easily, because the code is already online, but your users are not seeing it. And basically a feature flag is a sophisticated if statement, or it's an if statement. For example, the way we are doing it, we have very small components on our side, like 200 components on one page, and if we want to develop a new component, we have this has access method, which just returns if a feature flag is active for the current user or not. And you can have if statements everywhere in the code base, and Benjamin also showed you some ways how to do it in a nice way in Symfony. Of course, there is some logic behind this is active method here, which is basically, is this feature visible for the user or not? And you can then get very creative with what kinds of signals you put in there. You could do something like only make it visible for special countries, for special roles, like only for developers or only for testers. You could maybe say, okay, I want to put it online only for 10% of my users to test it out. And even more if you have, it depends on an application environment. That also means automatically you get the possibility to partially roll out new features and test it, which is really awesome. Who's doing partial rollouts in their application to only roll out new features to a certain type of users? It's a very good way of testing and seeing if something works. For example, you could say, okay, I have my main market, which is Europe, but I also have some users in the United States. But they are not as important for me. My main market is here, my money is here. The United States is just not that important, it's much smaller. So you could say, okay, I release stuff first in the United States, see if it works there. If something breaks, it's bad, but not as bad as it would break in Europe. And then you can iterate over that until it really works. It also automatically makes it very easy to do A/B testing. Like you have two versions of one feature. You develop both, and you set the feature flag for version 1 on for like 50% of the users, and the feature flag for version 2 also on for 50% of the users, and then you measure which version works better. You automatically have this then in place if you're doing feature flags. If you have any kind of other ideas how to do continuous deployment and how to do a development process, it's also fine. The goal should be for you to work with your company, to work with your developers that you have, and to integrate everything as early as possible and have small change sets. So now that we covered the development process, we somehow have to get our code live. And in order to get our code live, in most projects there is something called the build process involved, because we have our PHP source files, our JavaScript source files, our CSS source files. At some point we have maybe to do something with this. That could be running Composer to fetch dependencies, running Bower to fetch JavaScript dependencies, or NPM, maybe building some kind of JavaScript there, minifying JavaScript, minifying CSS, minifying HTML, building up static caches, for example, for Symfony, and so on. And these can be kind of like 10, 15 tasks you have to do in order to make your code production ready. And if you're doing this 15, 20 times a day, you should automate this. So look into tools like Ant, Thing, Grunt, Gulp, Broccoli, or any kind of other custom scripts that do the job. It doesn't matter what, automate it. It's really worth it to just have like one command, build project, and then everything is done in the same way for everyone. And you can't forget anything. Also, it should be fast, of course. If it takes like 20 minutes, it's probably, you're automatically limiting the amount of deployments you can do by day. So if you have to build for 20 minutes and then you have to fix a bug and then it's critical, you have to build for 20 minutes again, and then it actually takes like 25 minutes to deploy. Also, what you can do is, or should do, is hook these build processes into your continuous integration system. Like with every commit, just build a project. Then you see, even if you don't deploy it, then you have like a potential deployable artifact. Like a code base you could potentially deploy, and you see that everything is still working and not some syntax error is somewhere in PHP that would then break everything. Doing that also helps you improve quality. Once you build the project, there is deployment. Also, the same as building the project, deployment, so getting the code actually to your servers, it should be automatic, and as automatic as possible. That does not mean that with every commit, the commit gets automatically deployed. There can be like a manual step in between this, say, okay, I click here and then it gets deployed, which is usually a good thing, like doing a one-click deployment thing, or entering one command with a command line, but it should be nothing more. It shouldn't be like SSHing into 15 different servers and rsynching it over, and then checking something there and switching symlinks and all that. That should be automated. Also, it should be fast again. If you're doing it 20, 30 times a day, it should not take 25 minutes. And also, because we are doing it 20, 25 times a day, it can always be that no software is bug-free, that we introduce new bugs, so rollbacks should also be very fast, like rolling back to the earlier version. There are also tools for that, like naming a few, Ansible, Capistrano, Etsy has some tool called Deploynator, and also custom script. Everything is fine there. You should just care about it. It should be maintainable, it should be fast, and you should automate it. When you're doing lots of deployment every day, there are a few additional things you may need to think of. Because deploying new code means, for example, that certain caches are empty. For example, your opcode cache, APC or opcache in the newer PHP versions. When you deploy new code, you restart basically or reload your Nginx or Apache or FPM, and then the opcode is empty, and the first request hitting it will probably be very slow. So what would be kind of good is to add to your deployment script some kind of cache warm-up things, where you just do a few requests to your servers before you put them back into production, so that they get a warm-up cache, and not all of the requests are very slow at the beginning. Same with asset invalidation. With asset, I mean CSS, JavaScript, HTML templates, everything you have there that gets loaded from your CDNs. A common way to invalidate that, because you're deploying new JavaScript and browsers cache usually your JavaScript, so you want to invalidate that the new JavaScript is also used by your users. A common way is that to have just like one cache invalidation flag as part of your path and URL, and then you just say, okay, I had before that version 1, now I have version 2, the URL changes, browser fetch new CSS and JavaScript, and you're fine. If you're doing that 20 times a day, that means you 20 times a day you invalidate all of your JavaScript, all of your CSS, which is probably not kind of ideal for performance reasons. So better would be to just invalidate the files you actually only change, which means you build a hash over the file or use an e-tag for that. There are already lots of plugins, for example Grunt or Gulp plugins, or also ThinkTask or something over there, helping you with that so you don't have to develop it all on your own. Then, if you have all these things in place, you may think, okay, I've automated so much, I can automate even more. And oftentimes you also have kind of staging systems there. The staging systems, I mean, you maybe have like your developer machines where the code is running while they develop. You may have a central developer environment where like leading edge code can be tested in a central way, maybe by product managers, maybe by designers. You have maybe another integration environment also where you test it in a like clean database that's maybe copied by production, and then have your near production environment, or maybe also a near production environment, which is code running on the same database but different from your other servers in the production environment, but the same databases. When you have something like this in place, it may be a good way to build kind of an automated build, test, and release pipeline to have all your integration tests, your smoke tests, everything in place to automate this as much as possible. It could look like this. You say, okay, I'm committing something and I'm pushing it to my repository. Then automatically the continuous integration task is running and it's deploying it to my central dev environment so other people can test it. Then it runs all tests, all unit tests on CI and checks all the checks and sniffs and stuff that I have there on the CI server. And if they pass, I'll also deploy it to my central integration environment, which has a clean database. I may then run against this environment HTTP integration tests and acceptance tests and all that. And if they work, I automatically deploy to my near production system. So I could also test it then if I wanted to manually on the near production system. And then if it actually works, I can say, okay, I manually trigger a deployment to production with one click or so to get the code to be live. And these kinds of pipelines can help you also greatly to ensure quality. Of course, you have to look at speed there as well. If this pipeline takes like an hour in total to run, it's also then not ideal. So speed is still very important there. One thing that also maybe could be more complicated when continuously deploying new changes and new software all the time is schema migrations. With that I mean changes in your database schemas. Of course, if you have a NoSQL solution for databases, it's not that much of a problem because they are mostly schemaless. But if you're using MySQL, Postgres, or something, that could be a problem. So, what do we do when we have to change schemas or migrate schemas when we do continuous deployment? A good solution is just don't do them, or at least don't do them or only do them in a non-backwards compatibility breaking way. With that I mean, you should only do safe operations when changing schemas. Safe operations are, for example, if I add a column, that's safe because my old code still works with the additional column. And a safe operation would also be dropping a column if my code is not depending on it anymore. That means you should probably do migrations not like in one thing, but in steps. A flow could, for example, be if you need to change the type of a column for some reason because it's probably not long enough anymore or the type changed. You can add a new column with the desired schema that you want to have to your database. Then you change your code in a way that it writes to both of these columns in parallel. Then you write a small script or an SQL statement. You deploy that, then you write a small script or SQL statement migrating all the old data over. So that actually then it's still written to both columns. Then it's all in sync, both columns, the old one and the new one. Then you change the code to actually read from the new column, and then you can save, and you remove the writing logic, and you can safely drop the old column. Of course, this takes a bit longer, but it's a safe way without any downtime to change database schemas. And if you think about it, and the problems you have, usually you can boil it down to somehow like the steps. It takes a bit more work, but it's much safer to do, even if you're not doing continuous deployment. So we have all this in place, but still no software is bug-free, unfortunately. If you're doing continuous deployment and deploying all the time, you should make it as easy as possible to find actually the bugs and the causes. Of course, we have a small change set that makes it easy to detect something, but sometimes that may not be enough and the error is somehow hidden somewhere. So for detecting errors, the first thing we may need to look at it, that we find out actually that there are errors on the platform are error logs. So we just SSH into our 500 application servers where PHP is running and look at the error logs there. No. So my screen is not big enough for, like, it's probably big enough for 3 servers or 5 or 6. I can handle that with log files, but 500 servers running, like, I don't know how many thousands requests per second. That is kind of not good to see them anymore. So we should invest in something like a central log management. It means we aggregate all the error logs and all other logs we have somewhere in a central server, where we make it full text searchable, aggregatable, and we have dashboards and alerts and alarms where we actually see when something is happening. One solution would be, for example, like using log/Elasticsearch Kibana for it, so having logstash is a small daemon where I can aggregate logs from somewhere and put it somewhere else. Put somewhere else, for example, in Elasticsearch, where I can directly search over that. It, of course, takes a bit of hardware. I need dedicated servers for that. I should probably not put it on my production database or Elasticsearch cluster, because if I have a spike in logs, then my production Elasticsearch is also probably hit very hard. But it's worth it to invest in that, to find it. Then there are also like regressions or things that are not really visible in error logs, unfortunately. Like you can have logical bugs, you don't see any exception there, but some metrics are dropping or something is not working as it was intended anymore. For example, you forgot a save statement somewhere, change in the user account is not saved anymore. There's no exception for it, it still works, but not as intended. Same with performance, something just gets slower with KPIs. KPIs are dropping somehow, signups are dropping for some reason without exceptions that I see because of everything. To find out that as fast as possible, it's very important to just measure and plot and graph everything that happens on your platform. There are also tons of tools about that. One, for example, is Graphite, which a lot of people use, which is open source, but there are also hosted tools and everything that can help with it. And the idea behind it is every interaction that happens on your platform, be it SQL query, be it a request, be it a sign up, be it a click on a button, just send this as a counter somewhere, measure it, and also measure how long it took, like how long the queries took, that you directly see everything. Of course, you get a lot of data and a lot of graphs there that look hopefully like nice like this. But with nice things like an anomaly detection over it, it can directly show you, okay, in this graph I have an abnormal behavior. For example, I have a spike here in the last hour. This is something that normally does not happen, so you probably should look into it why the spike is here. And this also can help you, if you build nice dashboards around it, can help you greatly to improve your software quality and finding out bugs. Another way to find out what's happening in your application is through profiling. With profiling, I can directly see in my environment how a request behaved and how it worked and which function were called, how long they took, and why something happened like it was. So one tool, for example, for that is XHprof. You can run it in production. It makes your request a bit slower, but you only run it for like 1% of the requests. It's usually fine, or 0.1% of the request. And then you see with the request it measures directly what functions were called, how long they took, what the memory usage was, and you can also make aggregations over more of the requests. XHprof on its own is very basic in it. It just basically shows you a call stack. There are tools upon that make it even more flexible and easier to use to show you more detail on what's happening there. There is, for example, the Kahoot profiler. There is also a SensorLabs profiler. There is New Relic, which gives you a more high-level view on all of this data, which shows you, okay, in this request, these were the SQL queries that were run. They took this long. These were the cache requests that were done. It also aggregates this over lots of requests, so you can actually have statistically and historical data in there, and stuff like this can also help you greatly see what's happening in your code base and finding out the bugs, especially when you then also correlate this with the deployments you are doing. I think you can, now it's not shown on the screen, but you can imagine it that you can overlay your deployments in this graph as well. So you have like a vertical line here with every deployment you are doing. And then you can see, okay, there was a deployment, this graph spiked, so it probably was because of this. Or just use the stuff already in Symfony. They have this nice debug toolbar that is built in Symfony, where you also have like information like this directly visible for developers. And what you also can do easily is not only have this use this toolbar for developers when they are in dev mode, but you can also activate it on production. Of course, you should not show the toolbar then, but you can still collect the data for a subset of requests, maybe like 1% or so. Collect the data, write them somewhere to MongoDB and aggregate for that as well. And you probably also already have seen all these nice things. And then, if you want to go even further with that, it's also very easy to extend these kinds of things with your own modules. So you have application-specific things. For example, in your shopping system or something, you can extend this, write your own collectors there to also collect more data that is specific to your application to make it easier to find out what's happening in your requests. And just these are some screenshots from ResearchGate, what we are doing. There in our toolbar, for example, we extended heavily this timeline thing where we added more points to that than Symfony itself is measuring to get a better overview of where and which components we spent the time in one request. We added components where we have actually all the database calls, all service calls measured there, how long they took from where they were, and in a nice graph to show exactly in a tree what was slow and why and where it was called. And when you all aggregate this over each other, you get like, this is a screenshot of a dashboard from our site. You get like a very nice view on one page, for example, which is a jobs detail page where you see how long it took on average and an upper 90 percentile, and what components on the page were, and took how long, which database calls were in the end, how long they took to actually really see what's happening and optimize the things. And this this makes sense anyways, and combined with continuous deployment and seeing all these changes here. For example, here you see it, that every vertical line is one release, and you see we had here one spike after one release that was probably very bad, and then we did another thing and it went down again. So this makes it very powerful to handle and see what's happening in code base. And with all these, you can make continuous deployment successful. So to sum all this up, in the end, you should invest in your development process. This is a benefit, regardless of what you end up with. You should invest in quality of your software. You should invest in performance of your software. You should invest in agility to be as fast to iterate over your product as possible, to be able to change your product as fast as possible. And in the end, doing continuous deployment is a very good way to go about it. With that, I'm open for questions if you have any. If not, we can do two things. We have like 15 minutes left. I could go into more details about central log management if you want to. Who's up for that? Okay, I could go into more detail about profiling. Oh, this is now half-half, that is not fair. Okay, let's maybe try to split this a bit. This now takes, unfortunately, kind of a second until I get the slides. Okay. So, yeah, if you want to leave also, that's fine. I'm not offended by that. This is like bonus material now. And not everyone is into bonus materials as in movies. So, I started mentioning the central log management when I thought, okay, you have your error logs and SSHing into all your servers in there to see all the logs is kind of a bad thing because it does not scale very well. And also probably not every developer that you have has access to your production environment and should be able to SSH into your servers and do all kind of things there. So it's a good practice to aggregate all the logs in a central place and make them easily full text searchable. And also make them aggregatable with each other. Regardless of what we're doing with the central log management thing, you should always have a fallback and should always log to a file. Because I guarantee you that your central log management will fail at some point, and it will probably fail when you need it the most, when everything is burning. And then it's very good to have the fallback. You can still log into a file and see what's happening there. I'm serious. Log to a file. Please do it not like I did once. So with central log management, there are several ways to go about that. You could say, okay, I'm going with a naive approach. I'm just directly writing my log files when writing them to a file, also to a database. Would look like this. I have my PHP web servers, I have some database. It's hopefully not my production database, but a different one. And every time I'm logging something, I'm also logging to the database. If we log a lot, that could actually, and have a lot of requests, that could mean actually a lot of requests and inserts on our database, especially if something is burning there. Also, this is the Cronus process, most likely, inserting something into the database. That actually means logging something, means, okay, I have to create a TCP connection to another server, put an insert statement to there, wait maybe until it's finished, and then I can continue with my actual request that my user was doing. So my user has to wait in order for my log management to work. That is kind of not nice. Also, what happens if the database is down? How are my timeouts then? Do I maybe have like a 20-second timeout until my call continues and everything breaks then, and then I have like a response of 1 minute? Not very nice. What happens when the database is much slower, or even when it's full? It doesn't really work out. And it influences my application performance. Are there better solutions? Yes, I already mentioned them. For example, using something like Logstash, Elasticsearch, and Kibana, which offers full text search. And also something which allows us to store structured messages. Always logs to file, but we can do it then like this. A setup could look like, you have your web servers, they just log everything to file, like your error log, your access log, maybe also some debug logs that you're doing there. You could log all the database queries you're doing in case of an error or whatever. And then you have small daemons, Logstash daemons, running on each server that tail on these log files, put all the log files, maybe doing some analysis, some parsing on the log files to make it really nice and structured, and then send them to AMQP, like RabbitMQ for example. On another server, we have also Logstash running, listening on this RabbitMQ thing, and putting all the log files then into Elasticsearch. Why is this RabbitMQ in there? Because Logstash can talk to RabbitMQ, Logstash can also talk to Elasticsearch. Why I could not, like, directly from these Logstashes go to my Elasticsearch cluster? This is just load balancing. Because if I have 500 servers, usually they produce probably like 50 log messages per second. Something is burning, they produce suddenly like 5,000 log messages per second. If I have all this traffic in here and all these requests hitting Elasticsearch all the time, this will then break Elasticsearch. So I can have, like for load balancing, a queue in between here. This can handle a lot of requests. This can also batch a lot of requests. And then I can also hit it with 50,000 requests per second. I don't lose any messages. And my Logstash here in my Elasticsearch consume them just as fast as it can. Of course, I should scale it in the way that in a normal load area or load thing, I have a real-time or near real-time consumption of that, so that I don't wait for 10 minutes from logs messages to go from here to here. But if everything is burning, it's probably okay if it takes a bit more, because it's usually then the same log message over and over again that is causing the errors anyways. So, getting a bit more detail, how does this Logstash thing work? It's a simple daemon that has 3 stages, an input stage, a filter stage, and an output stage, and it works with a plugin system. So if input plugins, then filter plugins you can use on these messages, and output plugins where you could get the messages out. So config file could look like this. I have like an input for a file where I tail over my error logs and my access logs from Apache. Then I'm filtering these messages, for example, to pass my access log into a nice message because it's basically a line of string and I want to have all the information in there, like the IP address of the user, of course anonymized, the request method, the request, maybe the session ID and everything. I want to have this parsed in a structured way so that I can, for example, see all log messages of one session ID with an easy search. So this is basically like a regular expression pattern in here. And then when I'm done with all the filtering, I can just output it to RabbitMQ. And on the other side, down here, I have one input, which is RabbitMQ. I can filter it again to maybe tag it and make it easier visible, that certain exception types get like a tag that they are very serious and should be handled, should be really, really fixed, and other stuff is probably, yeah, there was a timeout talking with Facebook or the API. Okay, that can happen. It's probably, if it doesn't happen like all the time, I can probably forget about it. It's nice to know. And then you output it to Elasticsearch, and then for Elasticsearch there's a very nice front end called Kibana, which is looking like this and gives you very nice graphs and lists over that, and you have the full power of Elasticsearch to search over your logs. Initially, to set this up, you need probably like one server to handle, like, have a RabbitMQ there, a log session there, and Elasticsearch to just test it, and then put a log session on there. It's probably takes like a couple of hours initially to set this all up. Especially Logstash is very easy to use. There's very good documentation of it. It's also very powerful, so you even can do stuff like throttling in there, that you say, okay, if a certain type of message comes more than 500 times a minute, then I'm probably not interested in like more than 500 times a minute, so I'm just throttling and throwing them away. You can even have hash verification in there if you need it for some reason, and so on. Let me get to another point there. Other questions about central log management? Yes?
Is there any limitation in size on taking all that data?
The question was if there's any limitation in size, the amount of servers you have for it. So you can really scale Elasticsearch in a way that it's has very many log messages. I think we at the moment have 2 Elasticsearch servers that are not as big for central log management, and we store about 70 to 80 gigabytes log messages per day there, and have a retention time of 5 or 10 days, I can't remember. So we show all our log messages at some point away, and it still works very well with 2 servers. But I can't give you the specifications how fast or how big they are. You should have lots of RAM memory. So.
But you throw them away,
yeah, we should throw them away. Like, it's also important, log messages that are probably older than 2 weeks are not interesting anymore. If you need data from that for a longer period of time, just use something like Graphite or anything else where you just count stuff. For example, if you want to know how many requests I had, you're not interested in what exactly these requests were after 2 weeks or 4 weeks or something, but you're just interested on how many you had, and you can just then count them somewhere, which takes much, much less space, because it's a counter. Let me maybe go into a bit of more measuring thing for the remaining 5 minutes. I talked a bit about site performance earlier, and one important thing about site performance is how long did the request take to actually get to my user. So how long was my response time? So this is actually something I should really measure and put in graphs. So the easiest approach is to just get it out of the access logs. My access logs, usually there is in the normal log format the response time in milliseconds that a request took. So I can just for example, use logstash, tail over all the access log, pass with the grok thing my response time out, and maybe send this millisecond value to graphite then, because logstash can also talk with graphite, and then log my response time somehow. I can get even more sophisticated, maybe also pass all the URLs so that I do not only get the overall response time of my whole application, but also maybe based on URL passes or anything. Is this actually what we want to measure? Only the response time over servers? Of course it's important to know how long it took on our servers, but for the user, the response time on the servers is not the only important thing, because there's lots of other things there that's influencing website performance. There could be DNS resolving, the SSL handshake, there could be slow connection, then I have to load JavaScript, images, CSS, there are slow browsers that are slow with rendering stuff, there may be other external resources, agents requests that are doing somewhere. It takes much longer than these 882 milliseconds on my server for the user to actually see something that he can use. And that's actually what we want to measure as well. How can we do this? Only at the client side. Fortunately, there are already libraries for that. For example, this is Boomerang from Walk Normal. They offer a library that you can just, a JavaScript library that you can just include in your page. It uses some browser APIs, like the window.performance API, to get all the measurements, or it uses some measurements it does itself if the browser doesn't support it. And then you can just send these measurements somewhere back to your server and plot it somewhere. Like the usual way to do this is you have your JavaScript there, it checks all the timings, like really how long the request took on your backend, how long it took to make the DNS connection, how long it took to fetch JavaScript, how long it took to execute JavaScript, to render your DOM until like the DOM load event actually was called and finished. Then it sends normally just a request somewhere with all these measurements to a server you can specify. This server can also be externally hosted somewhere, so they offer also like a hosted solution. But you can also just set up an Nginx server somewhere. The request with all the tracking information as query parameters is then in the access log, and then you can also just have a logstash on there, tailing all this access log, parsing the timings out, and sending them to StatScene Graphite to graph all these measurements. And then you not only have the backend time, but also rendering time and everything else. And this, when you see it at first, will make you cry, because it's actually very slow, and much slower than you expected, because there are users in China and everything else, but then you can also optimize very easily and iterate over that. Okay, further questions on that? If not, then thank you very much for the attention, and I'll be here outside for questions as well, if you have private ones, and I'll also be, I think, tonight at 9 or something at the event that is later on somewhere, where people hopefully tell me that is at some point. I think I just have to read out. Thank you very much.